In this exercise, we are going to show that Pythagorean theorem does not work for n bigger than 3. So we are going to show that for all n bigger than 3, or equal 3 actually, a to the power of n plus b to the power of n is smaller than c to the power of n. This is actually interesting in the sense that why Pythagorean theorem only works for n equal 2, why not 3, why not 5, why not 6, right? This is a philosophical question, I know, but it is interesting to ask this kind of questions. And this exercise is somehow related to Fermat's last theorem, which states that there is no solution to this equation a to the power of n plus b to the power of n equals c to the power of n when n is bigger strictly than 2, okay? So yeah, this is a simple case of Fermat's last theorem, yeah, and we will show that. Please pause the video, give it a try and come back later to see the solution. All right, so what do we have here? We want to show that a to the power of n plus b to the power of n is smaller than c to the power, right? This is equivalent actually to say that a to the power of n plus b to the power of n power of 2 is smaller than c to the power of 2n. Now we can use the Pythagorean theorem. Then we have a to the power of n plus b to the power of n squared smaller than a squared plus b squared to the power of n. Let's assume without loss of generality that a is bigger or equal b. Therefore, if we factorize by b to the power of n, you get b to the power of 2n multiplied by a over b to the power of n plus 1 to the power of 2 is smaller than, we do the same here, b to the power of 2, we get b to the power of 2n, a over b to the power of 2 plus 1 to the power of n, right? We can simplify b to the power of 2n, and we get actually a over b to the power of n plus 1 squared smaller than a over b squared plus 1 to the power of n, right? So if we can prove this inequality, then we are finished, right? And this is actually, we can make a statement that for all x bigger or equal 1, it's to the power of n plus 1 squared smaller than x squared plus 1 to the power of n, with n bigger or equal 3, right? So how can we show this? We can try to use actually the binomial formula. It's to the power of 2 plus 1 to the power of n is the sum of k equals 0 till n and k, it's to the power n minus 3, right? Here 2n minus 3. Great. So this gives us h to the power of 2n plus some numbers till 1. And this one here is h to the power of 2n plus 2h power n plus 1. We want to show that there is a number here that is bigger or equal to the power h, 2 multiplied h to the power n. We can use two cases actually. We want to see whether there is h to the power of n. So we have 2n minus k equal n. This implies that k equal n over 2. And this makes sense only if n is even, right? So we can distinct those two. We can make a distinction that if n is even, then we have h to the power of n, h to the power of 2 plus 1 to the power of n equal to h to the power of 2n plus some numbers plus n factorial divided by n over 2 factorial to the power of 2, h to the power of n plus some numbers plus 1. Okay? And these numbers are strictly positive because h is bigger or equal to 1, and this number is strictly positive, bigger than h to the power of 2n plus n factorial divided by n over 2 factorial to the power of 2, h to the power of n plus 1. And now in order to finish our inequality, we have just to show that this number is bigger than 2. So this number actually n factorial divided by n over 2 factorial is 1 multiplied by 2 multiplied to n over 2 multiplied by over 2 plus 1 to n over 1 multiplied by 2 till n over 2, and we repeat the same thing. Great. So we can simplify actually these two numbers, and we get n over 2 plus 1 till n over 1 multiplied by 2 multiplied n over 2. So we can write it differently, that n over 2 k equal 1, n over 2 plus k over k. Now we can show that for all k between 1 and n over 2, you have n over 2 plus k is bigger than 2k. And this is very simple because this is equivalent actually to say that k is smaller than n over 2, which is actually true, right? Great. So this is bigger than 2. As it is bigger than 2, then we showed that this is bigger than 2, bigger than 2 to the power of n, 2hn plus 1, and this is actually it's 2 to the power of n plus 1 to the power of 2. Check, right? But for the case of n is odd, then we will go till n plus 1, right? So 2n minus k equal n plus 1, k actually equal n minus 1 over 2, right? N minus 1 over 2, great. So our h to the power 2 plus 1 to the power of n is h to the power 2n plus some numbers plus, here we are going to do n minus 1 over 2, h to the power of n plus 1 plus some numbers plus 1. This is strictly bigger, h to the power 2n plus this number here, n minus 1 over 2, h to the power n plus 1 plus etc. plus 1, right? Okay, just plus 1, remove this number. We need just to show this number is bigger than 2, and we are finished because this one number is bigger than h to the power of n, as h is bigger or equal 1, right? So in order to show that n minus 1 over 2 is bigger than 2, it's very simple. We use the same trick actually, that n factorial is 1 multiplied by 2 multiplied by n minus 1 over 2 multiplied by n minus 1 over 2 plus 1 till n, right? And we divide by 1 multiplied by 2 multiplied to n minus 1 multiplied by the same thing, by n plus 1, sorry, over 2, n plus 1 over 2, 1 multiplied by 2 multiplied by 3 multiplied by n minus 1 over 2 multiplied by n plus 1 over 2. Great. We can simplify, and this is actually n minus 1 over 2 plus 1 product of these two numbers, product till sum. We can write it differently. Wait, n minus 1 over 2 plus 1 multiply n minus 1 over 2 plus 1 plus 2 here till n minus 1 over 2 plus some number, I have no idea what that number is, multiplied by n. So n minus 1 over 2 plus that number equal n, then that number is it should be n minus this number, it should be n plus 1 over 2, right? Great. So what we are going to show that for all k between 1 and n minus 1 over 2, n minus 1 over 2 plus k over k is bigger or equal to 2. And this is very simple. We can say this is equivalent actually to n minus 2 plus k bigger than 2k. And this is saying that k is more than n minus 1 over 2. Check. And for the last part, this one, n over n plus n plus 1 over 2, it's bigger than 1. Then this whole thing is bigger than 2. All right? So now we show that this number is bigger than 2, and this is bigger than 1. Then we have 2 multiplied by its n, right? So we have this number bigger than 2. This one is bigger than h to the power of n. We do the product, we get 2h to the power of n. And at the end, we get h to the power of 2n plus 2hn plus 1 and this is our first n, which is x to the power 2. Okay, we showed our inequality. Where is that? We showed this inequality that we were trying to find at the beginning. Then we proved our first inequality that we had here. That's it. If you liked the video, please like, subscribe to my channel to help me grow. Thank you. Bye.